Swayam Prabha. Digital India. Educated India.
Hi dear friends, welcome to this first lecture of Module 10 on engineering geological facets of natural hazards and mitigations. We are going to discuss in this module about landslide, earthquake and induced seismicity. In previous lectures we have discussed about bridges, classification of bridges and their working, engineering geological facets of bridges, and building foundation, building type, etc. Now in this lectures we will discuss about landslide as one of the hazards. Friends, in this module we are going to elaborate about landslide. For covering landslide, we are going to discuss about introduction of landslide, then definition, then classification. Friends, as you know, the landslide is a catastrophic event caused by natural forces when a block of earth mass slides down. It is a detrimental type of natural events causing loss of life and property. It is typified as one of vicious natural hazards with major social and economical impact. The landslide has caused several disasters throughout the world, particularly in hilly region. In India, like Himalaya, in Nilgiri and other mountainous area. Throughout the world, time to time we have received messages regarding landslide, and majority of landslides are causing destruction to human society as well as property and disrupted communication, road network, rail tracks, etc. Therefore, this aspect concern to instability caused by natural hazards is very important to address properly, carefully and seriously. Friends, the causes behind the landslides are categorized as gravitational force and rainwater as major cause, supported by numbers of parameters which will elaborate in coming lectures in detail. Several researchers have attempted the problem to categorize different type of landslide due to lot of variation in geological strata ranging from fine-grained soil up to intact rock slabs or rock mass or rock strata. Initially, the courts had tried to classify landslide in different categories. Then later on, Varnes has worked on categorization of landslide, and Cruden and Barnes has proposed a significance classification including the type of movement, speed of movement and the type of ground condition in term of bedrock, in term of engineering soils made up of coarse materials, made up of fine materials. Cruden and Barnes in 1996 has presented the classification of landslide in tabular form, including all the possible parameters concerned to speed, type of movement and encountered ground. If we are going to see, we can see here type of movement is divided as fall, topple, slide, lateral spread, flows and combine. Then in slide we have two types of movement, rotational and translational. These type of movement, if encounter the bedrock, we are recognizing as a rock fall, rock topple, rock slide, rock spread, rock flow, etc. And when encounter the coarse swell, which is also recognized as debris, then the same type of fall we are going to attach with the material: debris fall, debris topple, debris slide, debris spread, debris flow, etc. And when the ground is made up of finer material, then we are going to recognize as earth fall, topple slide or earth slide, then earth spread, earth flow or soil creep. If the slides combining more than two are two, then we are going to recognize as complex type of slide. As far as fall is concerned, the fall is a fastest type of landslide. However, the creep is a slowest type of landslide. In case of fall, the blocks moves from upper gradient to lower gradient with very high speed, sometimes hits the traffic if exposed along the road, and damage number of vehicles moving on road, etc. Due to high speed of fall, it is very difficult to control such type of slide timely. One by one we are going to elaborate about each type of slide. First we are going to discuss about the rock fall. You can see the rock fall is a form where the ground or strata is traversed by a number of joints, here J1, J1, J2, J3 or more, which can able to divide the whole rock strata in different blocks. When the water is going to enter inside this, then going to push this block, and due to gravitational pull the blocks are ready to move towards downward. Before discussing the details individual, here I try to explain first about the landslide, how we are going to define about landslide. The landslide, if we are going to see about the landslide, here suppose this is the strata, it is of the slope, then due to any cause this detachment of the mass going to move towards downward and outward. The dimension width of this in cross section at the origin point is less, where the final accumulation of the material at the lower end at the toe side is wider than this. This indicates we can define landslide, the movement of geomaterial towards down or the movement of geomaterial down and outward under the influence of gravity. Gravitational force is going to pull the weaker or detached mass towards the downwards. When this detached mass going to move toward the downward, generally it is outward. So downward, outward movement of geomaterial under the influence of gravity is recognized as landslide. The landslide can be categorized, as we have already discussed, in different categories based on speed, based on bed encounter, based on type of materials, etc. The rock fall, you can see here, the expansion accumulation is wider in comparison to the intact dimension. The abrupt and extremely fast movement of geological or geomaterial like rock, like soil, like debris recognized as fall. However, the block of rocks, if moving fastly after detachment, then we are going to recognize rock fall. If the material is a debris, it is made up of debris, then debris fall. If it is made up of soil or earth, then earth fall. In case of fall, the speed of movement is very high. That becomes separated from the parent body in steep slopes and fall freely or bounce and roll down under influence of gravity. Gravitational force is going to pull down the detached mass, and this detached mass move with very high speed and finally settle on the lower side. Next type is a topple. Topple is indicating about the change of center of gravity. It can be categorized as block toppling, as fracture toppling, or both block and fracture toppling combined. You can see here, particularly in case of the prismatic type of arrangement concerned to the strata, if the water are due to any cause, if there is a slightly detachment, then there is a change in center of gravity. Center of gravity of this zone is different, but the center of gravity in the partially stable zone is different. In this way, under the influence of gravity, the material detached from the original parent rock can move down. So toppling is a common mode of instability in layered and blocky rock strata or blocky slope, where the rock blocks rotate about their toes and overturn. The toppling of soils or rock blocks take place along planes of joints or discontinuity by forward rotation with respect to point below the sliding mass, and the toppling failure is characterized by end over end motion of rocks. Gradually, here if this block is like this, due to any cause, if the water filled inside this, then going to create pressure, so it started moving along this center of gravity. The forces acting on center of gravity and others, due to this what happens, this portion is got detached and moved down under the influence of gravity. So in this way, if this one column is under instability, then other column, due to influence of this also started tilting. Due to this, the another strata started tilting, and finally they detached from this type of slides we generally experience in case of the extended rock strata traversed by number of discontinuities, or some layered strata traversed by one set of dominant discontinuity. This type of slides we generally encounter in case of columnar type of joints, prismatic type of joints, if present in rock strata. Next term is related to slide. and overall, if the land is going to slide, we are going to recognize as a landslide if regolith is present. But this term landslide, which was referred for the landmass, now we are going to utilize as synonyms for all type of slides. The landslide, you can see, the landslide is play between this gravitational force and the shearing stress and shear response of strata. If the shearing stress, that is the driving force, becomes strong, failure takes place along discrete or jointed planes called as slip or shear of surface, and the slide in rock strata always occur along the well-defined surfaces with downslope movement. For example, fault, shear zone, joints and bedded or foliated planes of rocks are usually act as potential weak planes, and the majority of landslide occurs along the weak planes. So gravitational force is going to pull this mass and drag towards the downwards and outwards. You can see downward and outward. The movement may be rotational, may be translational. If the rotational, then we are recognizing as rotational slide. If translational, then we are recognizing as translational slide. If we are going to see about different elements of landslide, we can see here the head. This marks the original ground, the periphery of the original ground from which the slides started initiating. Then there is a formation of main scarp, which is a remnant portion of the original ground. Progressively there is a formation of surface of rupture that become potential plane for slide of the detached mass. Along this, under the influence of gravity, the whole mass is going to move towards the down, and due to movement, what happens? This moving mass is showing number of cracks and fractures due to drag effect. When this started moving down, then due to drag effect between this intact original zone and the moving zone, forming transverse fracture. In this way, sometimes what happens, a particular part of the moving slide is started detaching from the original and become a secondary type of slides. At the toe side, there is a development of radial fractures, because here this thrust is acting to resist this from the toe side. Therefore, there is a formation of radial type of cracks or fractures. As far as rotational slide, and we are also recognizing in 2D as circular slide. This type of slide, generally the potential slide plane is circular or rounded in nature, along which the material starts moving detached and starts moving in rotational way. If it is a slide on the slide surface, then it is recognized as circular slope, and the landslide is a circular slide. If this material starts moving with this rolling type of activity, then it is called as rotational slide. This type of slide, which basically occurs in soil zones or highly fractured zones, or even in intact rock strata traversed by a number of discontinuity sets. The surface of rupture is curved concavely upward, and the movement is caused by rotation of the slide materials about an axis parallel to the ground slope and traverse across the slide direction. Because the potential slide surface is circular in nature, therefore we are recognizing as circular slide. Sometimes what happens, the slided mass started showing development of some another secondary slide surface or potential rupture zone, it is recognized. So the material lying above this secondary surface started moving as a secondary slide within the slided mass. Maybe development of new slide surface, so this material started sliding. This type of phenomena generally we are encountering in case of soil dumps, mine waste dumps, domestic waste dumps, etc., particularly in rainy season when this mass is under saturation, and after getting saturated this mass become heavier and prone to showing varieties of slides belonging to the circular slide of different dimensions. Another is translational slide, are also recognized as a planar slide. In this, the slide plane is a planar in nature, dominated by one set of joint like bedding planes or foliations or lineation directed dominantly in one direction. What happens here? Due to any cause, if there is a development of any discontinuity either traversed by joint, either due to fracturing, due to pulling of this block, in rainy season what happens? The rain is going to fill this gap, and due to presence of the water there is a development of the stresses which are going to push this block from the original block, and under the influence of gravity or under the own weight, this component following this slope direction is going to drag this block toward the down, recognized as a planar failure because the failure surface is a planar in nature, and also recognized as translational slide because the movement of the block is a translational, not rotational. During translational slide, movement of material takes place along a more or less flat surface defined by dominant one set of discontinuities or joint or bedding planes or foliation or lineation. Sometimes with a slide backward tilting, the surface of the ruptures are usually the contact plane between the rock and the overlying loose earth or intact material. Bedding planes, layered rock and other weak rocks in the rock strata or earth deposit is prone to such type of slide. A translational slide may be a block slide involving downslope movement of the sliding mass as a single unit or few closely related units as coherent mass. This type of slides we generally encounter along the roadside, particularly in Himalaya, having gneisses, sedimentary, bedded rock, etc. Another type of slide is a flow. As the name indicates, it is the flow of material, detached material. The movement of the masses is like the flow of fluid plastic in viscous state or fluid materials in viscous states. Depending on the material involved and the rate of movement, flows can be classified in four categories like rock flow, debris flow, earth or mud flow, and very slow flow, that is the creep. Rock flow, as indicated here through this diagram, you can see initially this mass is ruptured from the original ground and then started moving this trunk of the movement of the mass and then fanning out as settle at the toe side downward. See, rock flow is extremely rapid but less than rock fault. Massive flow-like motion of the fragmented rock or debris or swell from a large rock slides or rock fall as a secondary effect. The rock slopes involved in rock flows may vary from 45 to 90 degree, and debris avalanches are debris flow if the material is consisting of coarse materials, coarse soil, that is recognized as debris. The rapid movement of shallow non-cohesive or loose material down a steep slope is recognized as debris flow. This type of phenomena generally occur in heavy rainy seasons and creating lot of problems, even choke the river valleys, etc. Sometimes creating damage to bridges constructed on the localized rivers, etc. The heavy rain is called as a cause behind the debris flow and is most destructive type of landslide covering different area as the outer side is spreading for larger area, so going to damage large areal extent of the society. The variety of debris flow in which the movement of the material is sudden and very rapid, it is approximately more than 5 meter per second, is called as a debris avalanche. The avalanche, we have different type of avalanches, glacier avalanches and others. The debris avalanches is common in hilly terrain with the slopes having thick deposits of loose overabundant fragmented rock materials and inclination only 20 to 45 degree. 45 degree is our natural slide surface. Next is earth flow or mud flow. As the name indicates, it is the flow of mud or soil type of material during the rain from the clouds. As a result of heavy rainfall in the hilly terrain of the moderate slope constituted of the soil or other finer material is immediately cause earth flow, and if the earth flow contains material as high as 50% of the fines, it is normally called as the mud flow. So if the materials belong to clay and silt, it is recognized as mud flow, and if coarser than this sand size and finer sand size, then it is recognized as. This type of problems we have in number of locations, particularly in area having stratigraphically recent rocks, loose materials and others. Shivalik mountain chain is good example. In addition to Shivalik, Nilgiri also good example, and number of locations we have. Another aspect is a solidification. It is a very complicated type of problem, a special type of earth flow seen in high glaciated area resulting from the thawing of ice that fills the intergranular spaces within the clay and accelerate about the movement towards the downward. When the ice melt, the whole mass become waterlogged and unstable due to increase in weight and leading to downward called as solifactions. You can see one view of this, and it is a fact downhill creep or flow of any mass involving creep, frost heave and collapse are responsible for such type of activity. Creep is a slowest phenomena, cannot be observed properly through naked eyes, but we have different indicators which can indicate about the creep phenomena, like tilting of poles, like soil ripples, like curved tree, like the change in alignment of the fences, etc. So this is a very slow movement of partially viscous soils or rock material, generally few mm to few centimeter per year, and it brings about permanent deformation without developing discrete failure planes, and in the shallower part of the slipping ground exceeding slow movement takes place, minute slip planes. Therefore it is very difficult to recognize creep, and the real deformation occurs at the grain boundary and within the structure of clay. This type of phenomena is very dangerous because initially it was very slow, but later on the speed we have recognized was very fast as per evidence of past creep dominated landslide. Friends, these materials I have prepared from the paper written by the Gruden DM and Varnes DJ in 1996 about the landslide types and processes, edited by A.K. Turners and R.L. Chusters, namely proceeding named as Landslide Investigation and Mitigation Transportation Research Work Special Report 247 and page number 36 to 75, published by Washington DC National Academy Press, and then partial supports from these books of Engineering Geology written by Gangopadhyay, Wells FG, and the textbook written by Kashabolu NC. Friends, today we have elaborated about the concept of landslide and about the destructive impact of landslide. Then we have categorized different type of landslide, and landslide can be divided into different categories depending on type of movement, speed of movement, and material involved in slide. And the fastest movement of rock body is recognized as rockfall, soil body, soil fall, debris fall, and the slowest is the creep, generally occurs in case of soil. Dear friends, in this class we have elaborated about general features of landslide, about definition, about classification of landslide, and about the geoground in which such type of landslide occurs. Thank you very much for your patience.